15.1. Why are we going to Unit 15? This is going to make somebody mad, probably a fellow teacher down the hallway, but I don't know. We never numbered them in sequential order. And so we went from 12 to 15, and I have a feeling that our next unit after this is going to be unit either 14 or 13. So I don't know why we're going out of order. It is what it is, and I just kind of follow at this point. And next year, I will put everything in order as best as I can. But right now, what we're going to be doing is we're going to go down the road of sequences and series for Unit 15. You will recognize the first few types of problems from Advanced Math 8. The words explicit and the words recursive was something that we covered in Math 1 and Advanced Math 8. And those things you're going to recognize. What you won't recognize in the later sections are the things called series. That's where we add sequences together, and that will come later on in the unit. So imagine what you did last year as a stepping stone for what you're going to do this year. This year is going to take you a little bit deeper into the math behind all this stuff. Right now, what you need to know, we're going to be dealing with sequences of numbers. Some of them are going to be arithmetic. Some people pronounce this word arithmetic. Some people pronounce this word arithmetic. I usually call a sequence arithmetic. That's just my own personal preference. You could say either one and you would be correct. It just depends what part of the country you're from, I guess. Arithmetic, arithmetic. I don't know. Okay? When a sequence is arithmetic, it adds or subtracts the same amount. That's something called the common difference. As geometric sequences, on the other hand, are where you multiply or divide by the same amount every single time. And that is called the common ratio. We'll go into that in a later section. And there are others. Some that use square, some that you have exponential things going on. Anything else is considered other, and we are going to be primarily dealing with the differences between these two things, but there'll be a couple of these in the worksheet today. So that brings us to our first kind of formula, which is called an explicit formula. What I like and what I honestly believe, this is Mr. Paramo's personal opinion, explicit formulas should be the only thing that we teach. But for whatever reason, our textbook decides to teach recursive formulas, and it is on the S-back, and so we are going to have to teach you some other type of formula. But in my opinion, explicit formulas are the way to go. It's better because it's faster for bigger types of numbers. Explicit formulas are going to look something like this. There'll be a formula, and there's going to be something like an A of n, A sub n. This sub n just describes to you that it can be used to find any term number. I could use this explicit formula to find the first term or the second term or the 10th term or the 100th term or even the 1000th term in the sequence. That's what I like about explicit formulas. It can be used to find any term in the sequence based off of the term number. For example, if I wanted to know what the first term is, I'll call that A of 1. All I have to do to find the first term is to plug 1 into the equation and simplify it. If I want to know what A of 1 is, all I do is 4 times 1 minus 1. 4 times 1 is 4, minus 1 is 3, which means your first value is 3 in that sequence. If I want to know what A of 2 is, otherwise known as your second term's value, all you have to do is plug the 2 into the equation. So the second term's value would be 4 times 2 minus 1, or 8 minus 1, which is 7. If I want to find the third term's value or the fourth term's value, all you do is plug in that number and simplify. And after a while, you can kind of see a pattern that goes with it, because these formulas produce the exact same sequence every single time. 3, then 7, then 11. I could already tell what the next number is without plugging anything in. What is it? 15, if that's what you were thinking. And lastly, the fifth term's value would be 19. Maybe you'll notice the pattern, but there is a pattern that you are adding 4 every single time, which is why this equation has a 4 times. If you think about that, you're adding 4 because this adds 4 once, and if I want to go from here to here, you're adding 2 multiples of 4. If I'm going to go from here to here, I add 1, 2, 3 multiples of 4. That's why you're multiplying by 4 in that equation. We'll go more into depth in 15.2 on how to build these particular formulas. Anyways, A of n can find any term number. So A of n is the equation or the value of the nth term, where n is the term number. Like, I can plug in 1 for n, and that is the first term's value. Or if I want to plug in 4 in for n, that's the fourth term's value. I'm hoping that makes sense to you. This is how you're going to use it. As a matter of fact, this, I believe, is number 1 in your homework. So if you know how to do this, you're going to know how to do numbers 1, 2, 3, and I think 4 or 5, on that particular worksheet. Now the hard part is when you are asked to write the explicit formula. They're going to ask you, hey, come up with what you think the explicit formula is. And the key will be basing off what's happening to go from this number to this number. What's happening to go from this number to this number. Just remember, there is a relationship between what you plug in, the 1 and the 3. The 2 and the 7. The 3 and the 11. The 4 and the 15. The 5 and the 19. You have to get this number based off of the term number. When you think you know what it is, guess what you think the equation is. Plug in at least 3 values to make sure it works for everything. You'll be asked to do that like number 12. Number 12 says 1, 7, 25, 79, 241. I was working on this problem last night, and I go, okay, let's see. I'm adding 6. Okay, I'm adding 18. Okay, I'm adding, and I started to man, that's a big number, 54. Well, I'm definitely not adding or subtracting the same number, so that kind of goes, I don't think this one is arithmetic. So this one took me a while to do. So what helped me was this. I'm going to erase what I wrote down here. I also then checked to see if it was, what's the word? Geometric. Times by 7, times by 25 over 7, times by 79 over 25. It's not multiplying by the same amount every single time. It's not geometric. So it must be one of these other equations. Something that's not arithmetic, something that's not geometric. So then what I had to do is I had to do something like this. Okay, well, this is the value. This is my input. Okay, when I plug in 1, I have to get 1. When I plug in 2, I have to get 7. When I plug in 3, I have to get 25. When I plug in 4, I have to get 79. When I plug in 5, I have to get 241. So I have to think in terms of what I would plug into an explicit formula to get that value. So then I played around with squares. 1 squared, okay, that works. 2 squared, no, it doesn't work. 3 squared, no, it doesn't work. So squares, I throw that out. And I'm looking for patterns. Do any of you see the pattern yet? Ooh, Brandon, what'd you see?
Times 3.
Times 3.
Plus 4.
Times 3 plus 4. Let's see. 1 times 3 is 3, plus 4 is 7. Well, you're going from this number to that number. 2 times 3 is 6, plus 4. I'm not seeing that one. What do you got? What else do you want to try? What else do you see that you think might work? This is where thinking comes into play. You are going to have to think, and it's not just going to be easy because you have to think outside the box. What I did when I was here was I was playing around with it, and I started to notice something like, I started doing something like, I started playing around with this. 3 to the nth power. And the reason why I started thinking of 3 to the nth power was because 3 to the 0 is 1. 3, let me write this down as a pattern, okay? Let me write 3 to the nth right there. 3 to the 0 equals 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. Let's just write down what these look like so you can see. 3 to the 1 is 3. 3 squared is 9. 3 to the 3rd, 27. 3 to the 4th is 81. Let's look at these numbers. 1, 3, 9, 27, and 81. Pretty close, huh? The reason when I was playing around with different possibilities, this has a variable in the exponent. I was like, okay, that's kind of close to that. That's kind of close to that. That's kind of close to that. I'm almost there. I'm going to do something with this 3 to the nth power, but I got to do something to it to make it match up. Do you know what I have to do to make it match up? Do you have an idea of what this equation is going to be? If you do, please discuss this with your partner, please. I'm hoping you came up with something like this. You are going to have to play with different types of equations. If it doesn't go up by the same amount, you are going to have to play around with, it could have been x to the 3rd. It could have been 3 to the x power. I mean, that's kind of the stuff that you need to start thinking about when you're creating some of these equations. That's why I say guess an equation and then check to see if it works for at least 3 values. So what we should be doing now is we should be plugging in the number 3. 3 to the 3rd, 27 minus 2 gives you 25. Let's check this one. 3 to the 4th, 81 minus 2 gives you 79. 3 to the, that's really big. Let's go over here. 3 squared is 9. 9 minus 2 is 7. If it works for 3 values, you have nailed your equation. We've answered the first part of the question. Write an explicit formula for each sequence. Then what does it say? Then find the 10th term. So then what we get to do is use it. We get to find a of 10. A sub 10 means 3 to the 10th power minus 2. I definitely would recommend a calculator for this, because 3 to the 10th would not be fun to do without a calculator. It might be fun to do. Depends on how much torture you like. 3 to the 10th. I thought that was funny. I'm just tired. 59,047 is what I'm getting on the calculator. And I let the calculator even do the 3 to the 10th minus the 2 outside. Make sure that the minus 2 is not in the exponent. What I like about explicit formulas is I could use it to find the 10th term, the 100th term, and I don't have to just keep going and calculating things like that. But recursive formulas, on the other hand, are built off of the first value. If you know what the first term is, you can find the next term by doing something to the first term. That's the difference between this and recursive. It uses the same variable, so your n still is the term number. A of n minus 1 is used to take the previous term and calculate the next term. It's limited because you have to know all previous values to calculate the next value, meaning this. If you were to try to find the 10th term with a recursive formula, you first would have to find the first term and figure out what the second term is. And then from the second term, you'd have to calculate what the third term is. And then you have to use the third term to find and calculate what the fourth term is. And you'd have to do that 10 times to get to the 10th term. You could get there. It just takes a lot longer. So this formula looks a little crazy. Before I forget, in your packet, number 17. I played around with number 17, and I told you I was tired last night. But number 17, I was able to find an explicit formula for it playing around with the numbers. And then I tried to get it to be recursive, and I don't know if it was because I was tired or or what have you. I could find an explicit formula, but I couldn't make a recursive formula work for number 17. So I will challenge you with it. Maybe you can. Maybe you, being young and smart and vivacious, yes, you are. Maybe you guys can figure it out. And it's a challenge. Maybe you can. Maybe you get stuck like me. I don't know. You'll find out when you try it. Try it. See if you can outsmart Mr. Paramo. Challenge accepted. There you go. I couldn't find the recursive one, but I can find the explicit. Don't give it to me explicitly. I already know what that is. All right. Number 14. Write the first 5 terms of each sequence using the recursive formula. Guess what the first term is? The first term is -4. That's what A of 1 is. Now to find what the second term is, let's just go and pretend that we're finding the second term. What we do is we're going to use the second term -1. Well, what is A of 2 minus 1 means A of 1. So what happens here is whatever A of 1 is, we plug in for this piece. A of n minus 1 is actually going to represent the previous term, meaning I probably should put previous term's value. What's the value of that? If I want to use of that term right there, I plug in -4. That's what that's going to represent. A of n minus 1 is going to represent the previous term's value. I'm going to change that for the next period's class. So my second term is 2 multiplying by -4. Do you know what your next term is? It's -8. So to find the third term's value, you're going to do 2 times the previous term's value. 3 minus 1 means that you're going to be plugging in A of 2. And since A of 2 is -8, that's what you replace. And the third term's value will be 2 times -8, which is -16. You can do the same sequence every single time. You can just go A of 4 is 2 times the previous term's value if you want to, which is -32. And if you see the pattern, you can just continue it. We're just finding the first 5 terms. Negative 4, negative 8, negative 16, negative 32. I know what the last one is. It's going to be negative 64. Don't get confused by this notation. The notation is the only thing that I think that makes it a little bit confusing. It just means use the previous term's value. Lastly, write a recursive definition for each sequence. So, because something is happening to each term, that's how we're going to use recursive formulas. The first thing we do for recursive definitions is that we definitely need an A of 1. You have to state what your first term's value is. What is our first term's value? It's 120, because that's your first term. And then what we have to do is we have to, and I'm going to put first term's value. First term's value, because I don't think I did a good job explaining that. And then, if I want to find the next term, I do something to the previous term's value. There has to be an A of n minus 1 involved. This will be the next term's value. Let me just put a colon. Next term's value. What are we doing to go from here to here? And what are we doing to go from here to here? What are we doing to go from here to here? You can write, you're dividing it by 2. Some of you may not want to write dividing by 2. Some of you maybe want to multiply by 1/2. You're having that. That means the same thing, by the way. Either answer is correct, whether you did half of it, or if you did A of n minus 1 divided by 2. They both mean the same thing. But what you have to have in your recursive definition or your recursive formula is you have to have a first term's value, and you have to have how do you get to the second term's value based off of the first one. You have to use an A of n minus 1 in your formula somewhere. And that brings us to the end of our notes.